So again, this is 23.2, the start of it. We're going to talk about clouds and fog. Clouds, something you're experiencing today, a little bit of fog, maybe tonight, maybe. We'll talk about how that whole thing works. So we'll start with the objectives. We're going to describe the conditions that are necessary for clouds to form, explain the four processes of cooling that can lead to the formation of clouds, and that will be this day. On Monday, we'll identify the three types of clouds, and then we'll describe four ways in which fog can form. Now, listen, you've had the grandparent talk, the parent talk, somebody in your life, I'm sure, that told you it's going to rain. How'd they know that? Because they listened to the weather report, or because they looked up and they saw the types of clouds and said, oh, it looks like it's going to rain. That's how. It looks ominous. It looks like it's going to rain. How do we know that? Because we know things about the different types of clouds. The only thing you got to learn out of this is the names. And if you know the names and the shapes of the clouds, you can actually tell what's going on. And some of you, I can't speak to all of you about this because I don't know that it applies to all of you. But like for myself, for example, I can use I've sat at events or in a tree stand or whatever for hours in the rain with a raincoat on. How did I know it was going to rain? Could I listen to the weather report? No, not necessarily. It depended on what I saw outside in the sky. Did you ever hear, like, I always think about it as in terms of baseball. I don't know why I equate this to baseball, but I do. The whole thing with the leaves flipping over. Do you know what I'm talking about? In the spring here, the leaves start to come out, so on and so forth, or in the summer, especially when you have a whole bunch of leaves and the leaves flip over, you know it's going to rain very, 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 very shortly. Like it may look ominous, it may look like it's going to rain, but you have days that it looks like that and it doesn't rain at all or do nothing. But when you see this, the leaves flip over, it's coming. It is coming. That's the front, and we'll talk about that. And I guess with your language that you guys speak nowadays, it ain't no front. You know, it just is what it is. What's up now? Yes, mushrooms can go into a bowl because of the low pressure system, and we'll talk about that. So they collect water. Yes, very good. Very good. That happens. So let's talk about cloud formation. Clouds are a collection of small water droplets or ice crystals suspended in the air, which form when the air is cooled and condensation occurs. So for water vapor to condense to form a cloud, a solid surface on which condensation can take place must be available. So there must be something in the air for the water droplet to accumulate on. It's called condensation nuclei. In addition, for clouds to form, the rate of evaporation must initially be in equilibrium to the rate at which there is condensation. So there got to be enough energy in the atmosphere for the water to evaporate from the surface of the earth. Condensation nucleus is a solid particle in the atmosphere that provides the surface on which water vapor condenses. Although the lowest layer in the atmosphere, the troposphere, does not contain any large solid surfaces, it contains millions of suspended particles of ice, salt, dust, and other materials. So there's all kinds of stuff in the air. We just don't see it because it's that tiny or minute. Because the particles are so small, less than 0.001, which is tenths, thousandths, millionths of a millimeter in diameter, they remain suspended in the atmosphere for a long period of time. So the wind is strong enough, or the breeze is strong enough to keep this stuff suspended in the air. The diagram below shows the molecular formation of a water droplet. So you have salt crystals there on the left, and the water droplets accumulate on them. Hence, we end up with a, for lack of a better term, a raindrop. We end up with enough stuff stuck together that it will eventually fall to the earth. So this leads us to the idea of adiabatic cooling. So adiabatic cooling is a process in which the temperature of an air mass decreases as the air mass rises. So the farther you get away from the earth, the cooler it gets to a point. Remember, we studied this with the different layers of the atmosphere. So as mass in the air rises, the surrounding atmospheric pressure decreases. You hear how it says, as the air mass rises, the surrounding atmospheric pressure decreases. Thus, fewer collisions between molecules happen. The resulting decrease in the amount of energy that transfers between molecules decreases the temperature of the air. It gets cooler. What happens when it gets cooler? You get more condensation. What happens when you get more condensation? You'll eventually get enough condensation that it falls back to Earth. So when you hear the weatherman or lady talk about it being a low pressure system, what are we anticipating out of that? Precipitation. Because this is low enough pressure that it keeps rising till it cools enough that it falls back to Earth. Adiabatic lapse rate, the rate at which the temperature of a parcel of air changes as the air mass rises or sinks, is called adiabatic lapse rate. The adiabatic lapse rate of clear air is about -1 degree Celsius per 100 meters that the air rises. So as it goes up 100 meters, it cools 1 degree Celsius. The slower the rate of cooling of moist air results from the release of latent heat as the water condenses. So as this gas, this water vapor condenses into a liquid, it releases heat. So what happens is the air doesn't cool as quickly. Does that make sense? So it's releasing heat as it's changing from a gas to a liquid. Condensation level, when the air cools to a temperature that is below the dew point, net condensation causes a cloud to form. So when you see a cloud, it's because it is cool enough for the water to be condensing. The altitude at which this net condensation begins is called the condensation level. The condensation level is marked by the base of the cloud. So the bottom of the cloud is the condensation level. Above it, condensation continues to occur. Further condensation allows clouds to rise and expand above the condensation level. How many of you have ever flown in an airplane? When I say an airplane, I'm not talking in a prop plane necessarily, but I'm talking a jet. They go up above the clouds 30,000 feet or so, whatever. Did you ever fly through a cloud? Wow, it's not a good time. There's a lot of weird stuff going on. And if you're like me, I always opt for a wing seat because I like to see the wings do what they do. I love it. I don't know why I'm weird. But you see the wings go up and down, and you're like, ooh, 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 what's going on? It's because there's different rates of lift within that cloud. And when you get up there and you look out, you realize from your perspective, you see a cloud that's like, it looks humongous because it is. Some of them are 10,000 feet thick. Those are the ones that make incredible storms, not regular storms, incredible storms. Like crazy. There's so much energy as that thing is lifting. Wow. So what's the source of heat that warms the air that leads to cloud formation? The source of heat that warms the air and leads to the cloud formation is solar energy. As it re-radiates as heat by the Earth's surface, as the process continues, latent heat is released as a condensation, may allow the clouds to expand beyond the condensation level. So as this water vapor turns to a liquid and it condenses, it takes and heats, superheats, if you will, the air, and it allows the cloud to lift even higher. So like I said, you get some clouds that are like 10,000 feet thick. What do they appear like on the bottom? You see those clouds, what color are they on the bottom of them? Black as night. Those are the ones, thunder boomers, thunderheads, whatever you want to call them. There's all kinds of people have slang names for them. Wow. Wow, wow. It's going to get cranky. It is what it is. A couple more slides and we're done. So mixing. Mixing, some clouds form when one body of moist air mixes with another body of moist air that has a different temperature. So this combination of the two bodies of air cause the temperature of the air to change. So as these two things combine, hot and cold, we're going to get a mean, an in-between of this. The problem is, and you can see this, when the hot meets the cold, what do we get? More condensation. So we get more condensation. What do we get as a result? Precipitation. Because the air gets too heavy. The water droplets accumulate enough. It is too heavy. So this temperature change may cool the combined air to below the dew point, and the result, you get a cloud. Lifting is next. Air can be forced upwards when the moving mass of air meets the sloped terrain, such as mountain range. So one side of the mountain gets rain, the other one doesn't. These things behind me are mountains, but they're just babies, man. I'm talking Rocky Mountains or the Alps or something that's huge and gigantic, because as this stuff is lifted enough, okay, the thermals, the updrafts, as these things are lifted enough, it'll actually form clouds on one side of the mountain and not the other. As the rising air expands and cools, clouds form. The large cloud formations associated with storm systems also form by lifting. These clouds form when a mass of cold, dense air enters an area and pushes a less dense mass of warmer air upward. You guys familiar, before we talk about advective cooling, and that's going to be it for this day, are you guys familiar with, like, Oregon? That it rains like 100 inches a year? 80 to 100 inches? Precipitates 80 to 100 inches since they rain. The same amount of rain or precipitation that they have in the rainforest. You know that, right? And it's almost daily, because you have the warm breeze blowing off the Pacific Ocean that hits the Rocky Mountains, and boom, this lifting causes storms, and it rains almost daily. England, the same thing, right? England, the same thing. They have a wet and a dry season. There's a time when it rains almost every day, and then it's a part where it doesn't rain for weeks. A little different. So lastly today, advective cooling. Advective cooling is the process by which temperature of an air mass decreases as the air mass moves over a cold surface. As the air moves over a surface that is colder than the air is, this cold surface absorbs heat from the air, and the air cools. If the air cools below its dew point, guess what we get? Clouds. And Monday we'll start the classification of clouds. You have 5A1 to 5A3 was covered in your book today. Please, this is the note for everybody, please check your Sapphire. There's some of you that are way behind already. Kids, 8 weeks, we're out. 8 weeks, it's going to come in a heartbeat. 1 day off in those 8 weeks. So we're going to keep grinding. So you got to keep checking that Sapphire and keep up with us, because it's just going to keep coming. Yep. It's all good. Questions? Excellent. I am dead serious.